What's up everybody? Today we are going to talk about one of the advanced topics in .NET, and it is about expression trees. You will understand what is expression tree, why you need to use expression tree, and also in practice we'll develop application from scratch that will show you the real power of expression trees in practice. We'll develop ASP.NET Core Web API application which will use dynamic filtering, and through the dynamic filtering you will understand how you can properly apply expression trees in practice. So what are you waiting for? Let's dive in. First, let's see what we are going to build. We will have ASP.NET Core Web API with Entity Framework, and here is our endpoint. And this endpoint will provide dynamic filtering. So, for example, in this case, we have is active, which is equal to true. And when you send your request, you're getting, for example, ID 1 and ID 3. And I want to add more additional query params, like for example I want to filter by category, and my category is going to be array. So in this case I have name. Okay, let's do in this way, and I have the second name because I may have the multiple filtering arguments. That's how dynamic filtering is working. So user is able to provide dynamic query, let's say dynamic filtering, from the body in this case. And for example, I am looking for category which is equal to TV, which is equal to demo, and one more. In this case, it is going to be name, for example, internet. In my case, I have internet, I have TV. So they both are true, but I also have restricted filtering, like filtering by category, the TV, demo, internet. Let's search. So you see it is getting the same response, and I'm adding more constraint, like providing the name. Okay, so for example, I have LGMX here, so it is also array. Okay, and inside I have LGMX, and now it should return only one element because I'm looking for TV, demo, and internet categories, and here I'm looking for the LGMX. So here we have TV, internet, okay, but LGMX we have only in TV. So let's search, and here we are. So that's how dynamic querying working. That's how we are going to build our dynamic filtering using expression trees. Well, let's try to understand what are expression trees. Expression trees help us to represent our code in a tree-like data structure. That's all. So in simple terms, you have a lambda expression. Okay, this is a simple expression. This can be a completely complex expression. It doesn't matter. And you want to parse this expression, like you have expression as a string, and you can create sub expressions using this string. So you can take, for example, the first 10 symbols and the next 10 symbols, divide this huge expression into two parts, and then these two parts you can parse into smaller parts, and at the end you can reach to the elements of this lambda expression, take them out, and create another complete dynamic query based on this expression. That's how we are using expression trees. That's why we are using expression trees to create dynamic queries. So in my case, let's see what we have. So you see we have a simple lambda expression here, that x category equal to TV and x.name equal to Samsung. In my case, this is going to be a huge lambda expression. Okay, this is our lambda expression. Let's do a bit zoom here. So my lambda expression consists of two elements. In my case, I have parameter expression because it is x is going to be, so this side, this x is going to be the left side of my expression, and this huge part is going to be complete right side of my expression. Okay, so I have one huge expression. I am going to divide it into smaller ones where I reach each element of this expression. I can extract them and I can convert them into a different query. Okay, in my case I have lambda expression, so I have the parameter expression. X is going to be my parameter expression, and the right side is going to be complete binary expression. And also my binary expression consists of two binary expressions, because I have, let's say, so you see we have X category equal to TV. This is also a binary expression, and I have AND symbol here with X name equal to Samsung. This is the right side. This is also binary expression. So these two expressions together create a binary expression, but each of also going to be a binary expression. So my huge binary expression consists from two binary expressions, and in this case I'm going to parse this binary expression also to reach the final elements, like reaching to TV, the value constant expression here, and member expression. I want to understand which member it is, so it is category and equal to TV. I have name equal to Samsung. So long story short, you have huge lambda expression, and using expression trees you can create a tree-based data structure, and using visitor design pairing you can visit all the elements of this binary tree. These elements are going to be our nodes. So you see we have a node which consists of sub nodes, and you also may have a node which is a leaf node. It doesn't have sub elements. So this tree will help you to reach the final element. So in my case I have parameter expression. This is the final leaf element, and I also have member expressions here and constant expressions. They are final elements. I can extract any value like the category, like TV, from this expression, and I'm also able to convert this information, because I have the final information and I am able to convert it into a different query. For example, I want to generate SQL from this expression, so this expression helps me to reach to any element, and using these elements I will just create a dynamic in-memory query to the database, to the web service. It doesn't matter. So at the end you have a data which you can parse and convert it into different data structure, into different complete structure. Okay, that's what is expression tree. Great, now let's try to understand why we need expression trees. So in this case, so you see we have the lambda expression, and as we explained before, we have tree-based data structure which helps us to reach to any element of this expression. So you have the final elements like category, TV, name, Samsung, and based on this information you are able to build SQL query. So you see I have X category equal to TV, name equal to Samsung, and here I am able to convert it into SQL. That's how entity framework is working. That's how link to SQL, link to entity, link to anything is working, just simply using expression trees. The second example here, you can create link to services, link to URL. It doesn't matter. At the end you should convert it to different structure. Okay, here I have lambda structure, okay, delegate, and I am able to convert it into the URL structure. So from the link queue, from the lambda expression, you are able to convert it to the URL representation. Another example here, for example, when you want to create dynamic searching, dynamic filtering, okay, dynamic sorting based on your lambda expression. For example, we are going to implement complete application from scratch that helps us to understand dynamic filtering using the expression trees. And here simply what we are going to do at the end. So we have lambda expression. We'll convert this lambda expression to dynamic query to the SQL to get our data dynamically. So you don't need every time to type if, else's, etc. manually, all this step. We'll create an application which helps us to dynamically parse user provided data and convert it to dynamic SQL query. It is enough theory. Now let's switch to our practical section. In our practical section, we'll develop our ASP.NET Core Web API using Minimal API, Entity Framework Core, and of course, expression trees. I'm going to select our ASP.NET Core Web API template here, and let's name this Dynamic Filtering API, our project. Let's hit next. I'm going to use .NET 8. Of course, you can use even the classical .NET, even you can use 4.5, 4.7, they are also completely okay. So I'm just going to use .NET 8. Let's create this application. Let's go to our program section and let's remove unused files from here, unused code blocks from here, of course. So that's all. Now I'm going to install our in-memory database NuGet package. Let's go to install package Microsoft.entity framework core dot in memory. That should be all. Okay, let's install it. That's great. Now let's go to the project, right click, add new folder. I'm just going to call it the database. This is our folder, and inside I'm going to store our DB context. So inherited DB context, of course. It is going to be the product DB context. So I have product information, and for the product information, I'm going to build product DB context. Let's inherit from DB context. I'm not going to dive into details of working with entity framework core. You can check my other tutorials where I explain all this stuff from scratch. Great, and we'll have the DB set stuff. That's why I need right click, add folder, models, and let's create our product here. Okay, this is our product class. Okay, this product class will have integer ID. This is our entity, not domain driven design entity. This is entity framework entity. Okay, the public string category, every product has, it is category. Okay, every product has public decimal price, of course. Great, and we have public boolean is active, get set boolean information, and of course the product name, public string name. I think that should be all from the properties perspective. Now let's go to the DB set stuff. Let's provide our product. Okay, this is our product. Products get set, and from the constructor to make it available for dependency injection, we have DB context options product, DB context options, and let's inherit from base options. Great, let me just remove this stuff and format it like this. And also I have the override information. I want to let's say it's seed some data, override on model creating, and here we have model builder entity, we have product, we have has data, and I'm going to provide the least product information. Okay, and new product, this is the ID equal to 1, category is going to be our, let's say TV, is active true, name, and also we need our price, so 500. For the category it is going to be LG, let's say, and let me just copy and paste them like this. Okay, we have category internet. Now let's call it the mobile. Okay, we have iPhone, and we have TV is going to be Samsung. Okay, I think that should be all. This is ID 2, ID 3. Let's say it is false, not active. Well, that's all. That's all from the entity framework core perspective. Okay, and the only thing we are missing here is going to be our builder, services, and DB context, product, DB context, and let's from the options use in memory database, product DB. That's all. That's completely all from the entity framework core perspective. Now let's switch to our minimal API. Okay, so I'm going to use app.map get. So it is going to be the products endpoint, let's say, and I will do the dependency injection for my product DB context. It is going to be my DB context, and I need to provide some information from the outside as a filter information. So that's why I need product search criteria class. You can call it just product search, that's complete. Okay, I'm just calling it product search criteria. Okay, so what we have in our product search criteria, of course we have boolean is active. Okay, we have public prices, so it is going to be public record price range. This is going to be my decimal mean and decimal max prices. User should be able to provide minimum maximum range for the price. So user is able to provide only max, only mean, so we are going to make them nullable values. Okay, so price range, it is our price. Great. So we have the category information. Okay, let's public record category. In my category I will have the name. Okay, user should provide the name of the category, but this category is going to be price is also nullable, is active also nullable. We will be able to provide multiple categories. That's why I am creating a special model for the category. Okay, categories. Okay, let's call it categories. Okay, price categories, and the last one is going to be, let's see what we have. We have category price, of course we have name. So for the name I'm also going to use something like product public record product name string, just name like this. Okay, you can of course provide more better naming stuff here, but for the learning purpose that's completely okay. Product name, and of course it is also going to be array and names get set. So user will provide JSON information, will map it to our product search criteria, and from this product search criteria we'll grab our information and will provide it to our database using expression trees. That's the whole idea. Okay, let's go to the program CS, and here we should provide product search criteria, product search. That's great. Now I'm going to provide my migration stuff, DB context database dot ensure created asynchronously. Okay, let's provide a waitable. That's a simple entity framework core functionality. We should ensure that our database is created, and now we are going to work on expression trees with expression trees. So the expression trees, everything starts from the expression class. So you see this class lives inside system link expressions. Of course, all sort of inherited expression classes live inside system link expressions. So you cannot create this expression stuff like this. Okay, why? Because this expression class is abstract class. So now let's right click, go to definition, and here we are. This is abstract partial class. So you see this is just an abstract class, but we are able to create some sub elements, subclasses based on this expression class, because we have factory methods. Okay, for example, we have binary expression. This is inherited expression class which provides binary representation. We have constant expression, we have member expression, we have parameter expression, we have lambda expression. All these sort of expressions inherited from expression class. Okay, and just type expression, you will see multiple expressions like conditional, constant, default, dynamic, auto, blah blah. So you see we have tons of inherited classes here. So I'm just going to use my expression. What I'm going to do first, we need to understand what we are planning to do. We are planning to create lambda expression, dynamic lambda expression based on user search information. Okay, so it means in our product search, for example, we have is active. Let's start from the simple one. Okay, this is active is just a boolean value. So if user provided is active, what should we do? We should build in memory something like this: x dot is active equal to true against to our DB set. Okay, so if user provides the is active property from the postman, from any application, directly from the body, we should build this sort of expression. And if user provides, for example, names, let's say user provided two names, they are, let's say, A and B for the product. We should build something like this: and x dot name equal to A, or x dot name equal to B. Okay, depending from your business cases, of course, you can formulate this query. You can use not or but and, but in our case we are going to use or, because if user provides two names, it means we want both names. Okay, that's how we should dynamically build our lambda expression. And of course, after building all this sort of expression, you will just call your DB context. Okay, let's just remove this stuff from here. You will just call DB context dot products dot where, and you will provide this expression as an argument to your where, and we'll call, for example, to list, etc. Just map it to in memory stuff. That's our plan. That's how we are planning to work with expression trees. Okay, now let's start. As you remember, in our drawer here, we have this sort of expression tree diagram. So you see we have lambda expression and we have parameter expression with binary expression. So this is our parameter expression. First we need to build our parameter expression, because when you have some data and if you need to build expression based on data, mostly we start from the parameter. Okay, in our case, let's go to our application Visual Studio and let's call expression dot parameter. This parameter is going to build parameter expression, and approximately 90% of these functionalities are going to be factory methods. In our case, you don't have possibility to build parameter expression directly. You are building parameter expression using expression dot parameter. Okay, so in our application, we have the product list. Okay, in our DB context, we have product list. That's why this X should be in type of product. That's why I'm providing this product as an argument here. And the second one is going to be just X. So this X is going to be in type of product. That's how we are defining our parameter expression. So this is my parameter expression. This is let's call it parameter expression. Okay, let's just remove all these unused comments. That's great. Now we should specify our predicate stuff, because all other stuff is going to be our predicate. Okay, these are going to be our predicate. That's why I need to create my predicate first, and for that reason I'm starting with and condition. That's why I'm using expression that constant, which is going to be my main predicate. Don't worry, at the end you will understand why we are specifying it using the constant true. Okay, so this is our constant expression. Of course, I can use just expression here. Expression predicate. That's all. Let's format it. So I have X and I have the rest of predicate stuff, because this should be a predicate which returns true, false, etc. And why we are specifying true here, because in some cases we'll specify constant false to create or condition, but in my case I need to start from and condition. Okay, great. Now let's start from the product search. In my case, I will start from is active. So you see is active has value. Let's build expression which covers the is active part. Okay, in my case, let's go to our expression, and what we need to do, let's see, we need to do something like this: x dot is active equal to true. So we have this member expression and this is our constant. Okay, so and together they create binary expression. So at the end we should build binary expression which consists from member, the property of X, and constant. Okay, expression dot property. The property is going to be the property of my parameter expression. X dot what? Dot name of, let's call it the product dot is active. So I'm not going to use string stuff. I will just use the name of product is active. It means I've created this part. So the property of my parameter expression, which is X, and the is value, the name is value. So you see this is our member expression. Member expression, member exp. That's great. Now let's build our constant part. So it is going to be expression dot constant, and which is going to be product search dot is active dot value. The user may provide true, false. So it is also going to be our constant expression. Constant expression. Great. Now we have member expression, we have constant expression. We need to build binary expression. So where is equality? We don't have equality. So now let's work on equality part. Expression dot equal. Okay, and the left side, the member expression to constant expression, which is going to return, you see, the binary expression. Okay, binary expression that is Great. Now we have binary expression, and we need to build our predicate using something like a builder pattern. Okay, we started our predicate. This stores only true, and we need to add this binary expression to our predicate. That's why we will write predicate expression that and also. For the and also, will provide our predicate as a first argument. The second argument is going to be our binary expression. Why we are using and also? Because first we specified our predicate. This predicate should be the long predicate to match our lambda expression. But for now we have only the predicate something like this. But when we have is active, we should build something like this. We should have and x dot is active equal to true or false depending from user provided information. So we need to extend our predicate. That's why we are using and also to have this and also is active true or false. That's why first argument is going to be our predicate, second argument is going to be our binary expression. To test this, we need to specify our db context dot products dot where, and we need to send this argument, the predicate, as an argument to our where method. That's why this where method accepts expression func product boolean, and we need to build a lambda expression based on the expressions we have. So let's build our lambda. It is going to be the func product boolean. Okay, so you see we have the lambda right now, var lambda expression, and let's provide our lambda expression as an argument to where and to list asynchronously awaitable var data, and let's return results dot okay and data as an argument. So in my case, I need to specify our lambda expression. To build our lambda expression, I will provide our predicate first and our parameter expression at the second argument. Okay, that should be all. At the end, we should build something like this. It should have x dot is active x true and is active true false. Okay, so let's run our application and see if everything is working or not. Let's go to our postman. Now we have 7267 product and is active. Let's just send is active and see if is active is working or not. So this should be our get request. So we just need to change the argument definition here because we have product search criteria. We need to specify that it is from body. Let's run it. And that's all. It should work. Let's go to our postman and run the query again, and we should get two arguments. So you see we have two data, is active true, is active true. For is active false, we have only one data, so everything is working. That's great. Now let's switch to our second part of the implementation. They are going to be a bit complicated because we have the price range as an object, category, product name. So let's go to the first category, product search, categories, if we have any categories, or even we need to specify that product search categories is not null, is not null. Yeah, that's good. And let's create our for each here. It should be a category and product search categories. But for the category, as you remember, when we developed our is active, we need to specify the member name. Okay, we should have something like this: member expression property. So I'm just going to copy this and paste it here, and it is going to be my category. So I need to specify that I have x dot category. Okay, that's why we are building our member expression. And also we need to specify that we may have multiple categories, and we should provide them using or expression, not and expression. That's why I'm starting a special expression constant with false value. Why? Because we need our or. So let me type it: var false or expression. Let's call it or expression. Okay, or expression. And for every element we need to create our constant value, expression that constant, and it is going to be my category's name. Okay, var const expression. That's great. And now let's build our binary expression based on constant and member expression. So I'm going to specify expression equal, and I will provide my member expression and plus my constant expression. That's great. Now we have binary expression. So for every element we should have binary expression, but we need to specify that we have or operation here. So let's create expression or else with or expression and our binary expression. Okay, in our debug mode I will show you what we are getting at the end, and let's extend our or expression. But after for each done, so you see, or this is going to be binary expression, this is our const expression because we are building our constant expression. So that should be okay. So let's just call it expression to create expression. The parent class will help us to get this expression, and at the end we need to specify that it is and also expression. Okay, and we need to provide this as an argument to our predicate and or expression. That should be all. Let's add our debug breakpoints to see what we are getting at the end. Okay, so let's run it, and I'm going to build my categories. It is an array here. I have name for my category, I have mobile, and I have one more name, let's say, and it is going to be TV. Okay, we have two categories, we have mobile and we have TV, and we have is active. Let's provide true. Let's send our query and see what we are getting at the end. So let's continue. Let's see what we have. So you see we have is active true, and also for the false operation we have category equal mobile or category equal to TV. So one of them, we need to select one of them. Okay, so you see we have TV. For the mobile we don't have any value because is active is not true in this case. That's why we are getting two TVs. That's how we are working with our category now, and it is time to switch to, of course, product name. The product name will have approximately the same implementation. That's why I'm just going to copy this and paste it here. And we have names. If names is not empty, let's take information for the names. It should be product name because we are building x dot name. Okay, and we have product name here. Let's just copy it, paste it here. This is our expression, and that should be all. So for the names, it should also work. So as you see, I've changed only the product category information to our names information. So let's run it and see if everything is working or not. So let's go to the Postman. Let's create names, and it should be an array here. We have name. Let's provide our second name here. Okay. And this name. So the first name, let's specify Samsung. And the second name, let's specify test. So in mobile and TV categories, I'm looking for Samsung or test. So we may have Samsung test in mobile and Samsung test in TV. So that all type of combinations are okay for us. So let's run it. And here we are getting only one information, because in mobile and TV we have only one Samsung. So I'm just going to change it to LG, because in our TV we have LG. Now we are getting our LG information. That's how we are dealing with the combination of information as an array in our search argument. The last information is going to be our price range. This is going to be a bit different implementation. So if product search price is not null, then let's go for price, and I will check if product search price minimum is not null. Let's work on that. Otherwise, I will also provide product search price max is not null. So we have two special combination, because user may provide minimum information, user may provide maximum information. So we should check both if they are valid or not, if user provided this information or not. Now our combination is going to be something like this. We need to specify x.price. If the price information is valid, then let's create the min max combination. So for the mean, we should have something like this: greater than or equal to the provided minimum information. And for the x price max, less than or equal to the provided max information. Okay, so both combination is going to be something like this. So we should have a huge, let's say, expression with combination min and max like this at the end, if user provided both information. Otherwise, we'll have just price greater than or equal to minimum information, or price is less than or equal to maximum information. Great. Now let's go for the expression. First, we need to build our member expression, because we are working with price. So I'm just going to provide my member expression. Member expression is going to be expression dot property. Let's provide our parameter expression and name of product dot price. So we have member expression. It means we have x dot price, but we don't have constant values. So I'm going to build our constant value. So my first constant value is going to be price dot minimum if we have min information. So var const expression. And we have the constant value. Let's say user provided 400. Now we need to build binary expression based on this information. So let's go for expression dot equal. But in our case, it should be greater than or equal. Let's provide greater than or equal. Okay, greater than or equal, our member expression, our constant expression. So var binary expression. That's great. And based on this binary expression, we need to specify our and. So predicate is going to be our expression dot, and also let's specify our predicate and our binary expression. That's all. The same combination will apply for our max. So let's go just change it to max, and let's specify that we are looking for less than or equal, because we should specify less than or equal for our max value. That's all. That's our predicate combination, and at the end we are building our lambda expression and we are providing it to our products. Now I'm going to provide all these values. So we have the price, we have product name, category, and all this sort of information we have for the filtration. And let's go for it and see if filtration is truly working or not. That's why I'm just going to provide the breakpoint here. Okay, as you see, our current implementation, current filtration provides two information. Now I'm going to provide also the price filtration, which is going to be the minimum like 300, and the maximum value is going to be 3000. It means we should get these two information again. Why? Because the price is greater than 300 and less than 3000. So let's send and see. Here we are, and let me just add the breakpoint here and send the query again, and let's continue. And here we are. This is our expression. So you see we have price greater than or equal to minimum value, less than or equal to maximum value, and I want to test them separately. That's why I don't need to provide my max value. So I will just provide min value, and it should return again the same information. Or vice versa, you can just provide your maximum value, because we are looking for less than or equal for the provided value. And here we are. It should also return two information. Now let me provide our min value and with 600. So let's send it again, and we should get only one information. That's how we are dealing with expression trees. That's how we are building our dynamic queries against any data source that work with iQueryable and that requires our expression as an argument. That's all. If you like my videos, please don't forget to subscribe, hit like button, share, and I'll see you in the next tutorials. Bye.